Hey everybody, welcome back. This is probably the video you've all anticipated. We're going to wrap up the Roughness video series, and hopefully what I'll be able to do is kind of summarize everything that we've covered so far, talk a little bit about the need for standards, talk a little bit about the products that we ourselves have been testing, and a little bit about how some of these tests relate to one another. All right? So, Technidyne is one of the manufacturers of roughness testers. We manufacture the Beck test, we manufacture the PrintSurf test, we manufacture the Sheffield test. And we have probably, in the 15 years or more that we've been manufacturing this particular product, we have in excess of 400 units out there throughout the world. Okay, so we've tested a number of different products. I thought it might be a little bit fitting to bring you guys over to our shop area again and kind of introduce you to some of the products that we have used and we have tested for our customers and prepared our instrumentation to send out to those folks who have been fortunate enough or kind enough to invest in our product. If you look at anything from, we have a rough tissue product. We've got a semi-gloss, probably super calendared product. We have a lightweight coated product that we might have used, some newsprint that's not so prevalent anymore. We have some board material, backing material that we might have tested. We have got involved with companies that manufacture top coat, if you're familiar with that, for packaging grades. So you see that we've been able to cover a number of different products with our, successfully with our instrumentation. If you are a converter or if you're a manufacturer and you have any of your products that have some type of a roughness specification to it, there's a pretty good chance that one of our instruments has touched the surface of those products to give you some specifications. All right, I think a lot of people have heard the old adage that necessity is the mother of invention, and I don't think it was ever more evident than in our industry, that's paper making industry. There are a number of reasons why people have started to develop these test methods over the years. The printing industry in particular was a big driver. They needed to have our manufacturers create a product that had a smooth enough surface that when they laid down their ink, they laid down their images, they laid down their text, that those texts and those images came out nice and clear. So in earlier videos, we talked a little bit about the different ways that roughness is measured using the air leak method. All of those methods that we talked about, the 5 methods we talked about, all have one thing in common, and that is some means of creating a pressure drop across the surface of the sample being measured in order to create some air movement across the surface of that sample to be measured. If we were to take this as an example, of course, many of the tests that we talk about are using different backing materials, but they all are quite firm. Again, if we have a fixed platen, a fixed surface, that's, in our case, we're looking at optically flat. We're able to place that on top of the sample that we're being measured. We back that sample with some type of a firm backing. We're able to charge that cavity, if you will, with a fixed pressure. And when we do that, now the topography of the sample allows some of that air to leak out from underneath, and we measure that air that leaks out from underneath. So in each one of these cases, they're all trying to generate some type of air movement across the surface of the paper, the sample that's being measured. Again, if we go back many, many years, one of the driving forces, as I mentioned, were the printing industry. Printing industry in the 20s, 30s, even prior to that, into the 50s. Newsprint was a big means of disseminating information, disseminating news, disseminating special events and things of that sort. For the most part, in those early days, it was a regional type bit of information. So it was pretty easy for one manufacturer to be able to supply a couple of different printing houses with a product that was reasonable for them to be able to print on. Okay? Once we start looking at some global activity, like today, we're talking about products that are being made in China, in Asia, in South America, in North America, and Canada. So we need some type of a method, some type of rules, I guess, guidelines that everybody can follow and be on a level playing field when we're starting to talk from a supplier to a consumer and then back and forth. All right, so the various, let's say, industrial organizations that follow pulp and paper, that is TAPI, that's ISO, that's Canadian Pulp and Paper organizations, they've developed these test methods, again, with probably the expectations that they can use the information within these methods. Everybody's using a Sheffield test, for instance. They can use the information from that test result, communicate that to their neighbors, communicate that to their consumers, and then those consumers be able to communicate back to us, assuming they're using the same test methods that we are, and we have a good means of communication. As an example, the 5 different methods that we talked about earlier, the Beck, Benson, Gurley, Sheffield, PrintSurf, okay, they each have a specific method in order for the, let's say, the manufacturers to follow and the consumers to be able to judge by, but they're all different from one another. It's very difficult to communicate between supplier and between manufacturer if we're not using the same method, if we're not following the same method. Each one of these methods have something different. They have different units. They have different test ranges. They have maybe even a different application. They certainly have different test areas. They have different loading pressures. They have different platens. Whether you're measuring on a more or less macro size, okay, or in the case, which is Benson, or in the case of the PrintSurf, whether you're measuring on a micro size, that information has to be utilized when you're communicating between the manufacturer and supplier. So now, to make things even a little bit more complicated, within each one of these methods, there may be modifications within a Benson test, as an example. We're measuring milliliters per minute. However, if I have a particular product that's on the smooth side, if I do some testing, and for, let's say it's either a lightweight coated grade or a very firm board grade, that's a coated board grade, using for small box boards, my toothpaste packaging or my perfume packaging, that type of thing, that's going to be pretty low on the Benson scale. So in order to, let's say, move that measurement up to a more reasonable area, the Benson had decided to actually use a different pressure differential. They have 3 different pressure differentials, as an example. The PrintSurf test has 3 different loading pressures. They have 2 different backings. So even though you might be communicating with your customer, or customer might be communicating to you as a manufacturer, you might be talking about the same measurement, PrintSurf, Beck, Benson. You still have to dive a little bit deeper into these methods in order to be able to fine-tune that communication level and be able to come up with the right specifications and be able to understand, if there are some issues, understand how to correct those issues. So be sure to be very careful about not only which method, but also within that method, which sub-method that you're using. All right? Okay. Now we're on this communication thing. and the test methods that we're going to be using, I want to talk a little bit about measurement sensitivity. Okay, a good analogy for me to kind of understand this concept is with my speedometer in my car. Okay, I have a speedometer in my car that might go from 0 to 100 or 0 to 120 miles an hour. Okay, I might be driving in under a condition where, let's say I'm going through a toll booth. Okay, I've got to slow down to 5 miles an hour. All right, my scale on my speedometer, 0 to 120, is, when I'm looking at it, I'm measuring pretty darn close to the very edge of one extreme of that measurement system. Okay, so am I really driving 5 miles an hour? Am I driving 3? Am I driving 8? I really don't know. That's an important, when you're starting to talk about not only communicating these, let's say these specifications, but also when you're selecting the property, the particular test method that you're looking at. Okay, as an example, I mentioned with Benson, they have 3 different differential pressure settings that they have. Okay, if my Benson scale, typically I'll look at the Benson scale, and right now it's a good working range is 0 to 3,000 milliliters per minute. Okay, if I have let's say I have a particular sample. My sample is exceeding the 3,000 milliliter per minute range because it's so rough. Okay, and my pressure setting is at the high pressure setting. It could be even at the medium pressure setting. The medium pressure setting for Benson is about 150 millimeters water gauge. So if I'm exceeding that scale, I have an option within that method to back that pressure drop down and be able to utilize my working scale. The only thing is now I can't really communicate to somebody directly if I'm using a lower pressure drop and they're using what might be the normal pressure drop. All right. So just a little bit about just a little bit about measurement sensitivity. We have to be aware of where we are working in the scale that is designed for that instrument that we're utilizing. So I've covered, let's say, the development. I've covered the standards that we want to follow. I've covered measurement sensitivity, and I've kind of harped on the idea that if you're going to communicate to somebody, communicate to them with the same language. Okay, communicate with the same language. If you're using print surf, communicate print surf numbers. If you communicate Sheffield, communicate Sheffield numbers. Well, despite all of that, in reality, that doesn't happen. You're a manufacturer or you're a converter, and you have one instrument. All right, you have a Sheffield tester, you have a Beck tester, you have a Gurley SPS tester. Anyways, you have one instrument. And it's pretty expensive to go ahead and invest in another instrument to just simply to communicate maybe to one of your customers. Okay, so you come back and maybe you go to Technidyne or you go to one of your other instrument manufacturers and just say, oh man, I got to have some way of being able to convert my Benson numbers to a Sheffield, Sheffield to Benson, Sheffield to Gurley, or what have you. Okay, so a number of different organizations have certainly heard that, and they've made every effort that they can to try to create these conversion charts. We have, as an example, IPST might be involved, FP Innovations, or at one time Paprcan. Let's say anybody involved in the instrument research. They've all had some way of trying to communicate, trying to correlate, I guess, one instrument method to another. And you might see interrelationship modes along this way. As I mentioned to you before, however, each one of these methods use a different clamping pressure. They use a different backing. They might use a different annular ring, a distance that the air has to travel across. So all of these factors have to be considered when you're looking at this conversion. I'll give you an example. If I'm looking at Benson wanting to try and convert it to Sheffield, okay, I can find some type of conversion, but it's limited in the range that I can utilize this information and transfer this information to, okay? Benson, I might be able to go 0 to 1,000 milliliters per minute, when the actual range of the Benson test might be 0 to 3,000 milliliters per minute. So my normal product range, I might be able to be okay with Benson, but I still need some way to convert it to Sheffield. If I'm looking at trying to convert it to Sheffield, I have a reasonable conversion between 15 and 400 Sheffield units. So I've got the full working range of the Sheffield, but not the full range of the Benson. And again, I have to give credit to a number of these other organizations who have developed these conversions, these correlations, and tried very, very hard to be able to help people communicate, and again, primarily in a global fashion. Whether it's in a table that's drawn up similar to this, whether it's utilizing some type of a logarithmic scale to be able to convert one unit to another, whether it's some empirical data. Some people have done a number of tests using empirical data. I think myself that's probably a little bit more, let's say, closer to reality. But so that's our reality. Again, I may not be as a customer, a printer, or certainly as a manufacturer, able, let's say, have the means to be able to have a Beck tester, to also have a Benson tester, to also have a Sheffield tester, to also have a PrintServe tester, to cover all those means of communication. I may not be able to have that ability to be able to do that. So I am going to look at utilizing these conversion tables, these formulas and whatnot that other people have developed in order to get a ballpark figure of whether or not I can even come close. If I have a customer request, whether or not I can even come close to meeting their specifications. Okay, so that kind of wraps up hopefully the summary of the roughness testers that we talked about, the 5 being Beck, being Gurley SPS, being Benson, being Sheffield, and being PrintServe. Okay, what I'd like to do is bring you to another part of our shop. I want to introduce you to some of our instrumentation that we've been working on over the years to give you an idea of what we can do. All right, so thanks for joining us, and I'll see you in just a moment. All right, thanks for following me over, guys. Now, I mentioned to you I wanted to introduce you a little bit to some of our test equipment, certainly that Technidyne is producing. We have the capabilities of producing a top side and bottom side measurement system. Simultaneous testing to expedite some of the testing frequencies that you might be looking at. This guy is set up to test the Sheffield roughness test. This guy, again, top side and bottom side capabilities, but it's set up to test for the PrintServe test. I just want to give you a quick idea of some of our capabilities. Certainly we can also equip one of these with the Benson measurement heads and Benson measurement pressure systems. But just to give you an idea, we talked a little bit about, okay, how do I communicate one measurement system to another? It's still 2 instruments, but here at Technidyne, we do a lot of testing, a lot of preliminary testing for our customers. If I take this, it's a white top, semi-coated calendar sheet, and I do a quick test, I'll get a reading, a Sheffield reading. 310 Sheffield units. It's pretty high on the Sheffield scale, but if I take this same sample, insert it into our PrintServe test, do a quick test. Within a few seconds, I have some results. 5.6, roughly 5.1 microns. So also on the upper end of the PrintServe scale. PrintServe scale, I don't know if we talked about, but let's say traditionally might run from 0 to 6 microns. Sheffield unit tops out at 400 Sheffield units. So we're right at the top end of both of these scales, but we still can look and do some comparisons right within a few moments, get you that information, and certainly if you have some additional questions, we're always here to help out, and would be more than happy to try to address some of your questions, at least the preliminary testing that you might need to do. All right? So thanks a lot for joining us. Hopefully we've covered enough information, enough detail, at least for you guys to get underway and understand a little bit more about the roughness test. Thanks for joining. Bye.